to Chemistry Solutions. This is a GCSE revision video and it's taken from section 4.3 of the AQA syllabus on quantitative chemistry. The video is specifically about concentrations and solutions and associated calculations. It's relevant for all exam boards. Please feel free to pause the video as often as you like and as often as you need to. Concentrations and solutions, foundation and higher tier. What is a solution? Solution is made up of a solute dissolved in a solvent forming a mixture. So what's a solvent? A solvent is a liquid present in large amounts which dissolves other substance, called solutes. For example, meths, water. Solute, what's a solute? The substance that is dissolved by a solvent to form a solution. For example, salt dissolved by water. So let's look at a visual example. We've got a solution here from a solute, which is our salt, and our water is a solvent. The solvent and the solute mix together to form a solution of sodium chloride solution. Measuring the concentrations of solutions. Some solutions can be described as concentrated and some as dilute. Very crudely, concentrated means a lot of solute, not a lot of solvent. Dilute means not much solute, a lot of solvent. Now, chemists must be able to measure concentration because many chemical reactions take place in solutions. So the concentration of a solution is measured in grams per decimeter cubed or moles per decimeter cubed. So let's look at grams per decimeter cubed, as moles per decimeter cubed is only covered in the higher tier. Concentration in units of grams per decimeter cubed is the mass divided by the volume. The volume must be in decimeters cubed, but volumes are often given in centimeters cubed. So to convert centimeters cubed to decimeters cubed, we divide by 1,000. So let's have a look at a worked example. Calculate the concentration of a solution in grams per decimeter cubed by dissolving 5 grams of sodium carbonate in 250 centimeters cubed of water. So first of all, let's get the volume in decimeters cubed. So we do 250 divided by 1,000, and that gives us 0.25 decimeters cubed. Then we can set up a formula triangle, and the mass divided by conc times volume. That's our formula triangle. So the concentration is the mass divided by the volume. 5 divided by 0.25, 20 grams per decimeter cubed. So let's look at a problem. Calculate the mass of sodium chloride needed to make 100 centimeters cubed of a 4 grams per decimeter cubed solution of sodium chloride. Now pause the video, have a go at this and then restart and see how you get on. So the first thing you've got to do, remember, is to convert the volume from centimeters cubed to decimeters cubed, and we do that by dividing by 1,000. So 100 divided by 1,000, 0.1 decimeters cubed. Then we move on to the formula triangle. Try and find out what the mass is, and we do this by taking our finger, cover up the mass, and we end up with the concentration times volume. So we now know the mass is the conc times the volume. So now we're going to sub all that in to our formulas. So the mass is a conc times volume. So the mass there, the concentration was 4 grams per decimeter cubed. The volume is 0.1 decimeters cubed, so 4 times 0.1 equals 0.4 grams. All that we've covered so far is for foundation and for higher tier, but from now onwards, all our revision will be focused on what's required for the higher tier. Now, concentration can also be measured in moles per decimeter cubed, and this is the most common way of measuring concentrations of solutions, especially when you're doing practicals like titrations and such. So the formula is very similar to the previous one. The concentration in moles per decimeter cubed is the moles divided by the volume in decimeters cubed. Don't forget the volume in the formula must be in decimeters cubed, so we convert by dividing by 1,000. So let's have a look at a formula triangle. Now this one is displayed here, the moles, conc, volume. But there's a more familiar phrase or a more familiar way of remembering this as it rolls off the tongue, NCV. N for the number of moles, C for conc, V for volume, NCV. So let's do a worked example. 100 cubic centimetres of dilute hydrochloric acid contains 0.02 moles of dissolved hydrogen chloride. Calculate the concentration of the acid in moles per decimetre cubed. Convert volume to decimeters cubed, don't forget, by dividing by 1,000. So the volume's going to be 100 decimeter cubed divided by 1,000, 0.1 decimeters cubed. Using our formula triangle, we're working out the concentration, so we cover up the C. So the concentration is the number of moles divided by the volume. Then we sub in our numbers and we get the concentration is 0.02 divided by 0.1, which is 0.2. And don't forget our units, moles per decimeter cubed. Quite simple, really. So one of the things you could well be asked to do in an exam is to convert between grams per decimeters cubed and moles per decimeters cubed. Now, the relative formula mass, MR, is used in this process when we're converting between moles and grams. And to convert from a moles per decimeters cubed to grams, we multiply by MR. And to convert from grams decimeter cubed to moles decimeter cubed, we divide by the MR. So convert moles to grams, multiply. Moles, multiply. Remember that. So let's do another worked example. Calculate the concentration of a 0.1 moles per decimeter cubed sodium hydroxide solution in grams per decimeter cubed. The MR of NaOH, sodium hydroxide, is 40. Don't forget to convert from moles per decimeter cubed to grams per decimeter cubed. We multiply by the MR. So the concentration is 0.1. The MR is 40. 0.1 times 40. 4 grams per decimeter cubed. Let's try a few calculations. Remember, pause the video. Use what you've learnt so far. Restart the video. See how you get on. So the first one, calculate the concentration of the following solutions in moles per decimeter cubed. A, 0.2 moles of a NaCl in 250 cm cubed. Pause the video. First job, convert centimeters cubed to decimeters. So the volume is 250 divided by 1,000, 0.25 decimeters cubed. Formula triangle to calculate the concentration. The concentration is the number of moles divided by the volume. Sub in the numbers. Number of moles divided by the volume gives us the concentration. 0.2 divided by 0.25. That works out at 0.8 moles per decimeter cubed. Back of the net. Let's try another one. Calculate the concentration of the following in moles per decimeter cubed. 0.4 moles of H2SO4 sulfuric acid in 200 cubic centimeters. Remember, part 1, volume in decimeters cubed. So we divide by 1,000. 200 divided by 1,000, 0.2 decimeters cubed. From the previous question, we established concentration is number of moles divided by volume. We sub in the numbers from the question. 0.4 moles, 0.2 decimeters, 0.4 divided by 0.2, 2 mole per decimeter cubed. How about this one? Calculate the number of moles in the following solution. 200 cubic centimeters of a 0.2 moles per decimeter cubed HNO3. Now this one you are often required to, from that NCV triangle, to not only calculate concentration, but also the numbers of moles. So we use exactly the same idea and exactly the same strategy. Volume into decimeters cubed first by dividing by 1,000. So 200 divided by 1000, 0.2 decimeters cubed of the solution. Now let's look at NCV. We need the number of moles, N. So we cover up the N and we get the N, the number of moles, is the concentration times the volume. Sub in the numbers. 0.2 is the concentration times 0.2 decimeters cubed equals 0.04 moles. Now, there's one other category that comes under the solution type chemistry, and that is titrations. But I'm going to deal with that in a separate video because titrations are complicated and really deserve a video of their own. So thanks for watching. You can click the link at the end and subscribe, or you can see other videos that I've got on revision or exam paper walkthroughs. Thanks for watching. Bye.